Welcome to the On-Premise IT Roundtable, the only podcast that dares to be both on topic and on location. My name is Tom Hollingsworth, and I'm a part of Gestalt IT, and each episode we bring you topics in the enterprise IT space, and we invite luminaries from the IT industry to be guests on our podcast. I'd like to take a moment for our guests to introduce themselves before we dive into the premise of today's episode, starting with Terry.
Hi, I'm Terry Slattery. I work at NetCraftsman. We're a consulting company in the northeast part of the US. And I blog at NetCraftsman, I blog at NoJitter, and I blog at TechTarget. And no, I am not on Twitter.
All right, Chris.
Hey there, I'm Chris Cummings, and I am on Twitter at CrankyNetman, and I blog very infrequently at /64.tech and do podcasts and posts for modem.show as well.
And Pieter-Jan.
Hi, my name is Pieter-Jan Nefkens. I'm a consultant and author, and you can find my blogs on nefkens.net and on Twitter with PJNef.
All right, thank you all very much for joining us. Let's jump into the premise of today's episode. We all run networks. We have to do them because otherwise our computers couldn't talk to each other. And in the old days, we spent hours and hours and dollars spending on these giant, beautiful, well-crafted enterprise networks with wireless access points and perimeter firewalls and data centers to rival the most impressive companies out there. And today, no one uses them because everybody wants to go to the cloud, because all of our applications live in Amazon Web Services, because all of our databases live in Microsoft Azure, because all of our development projects live in Google Cloud. So our enterprise networks are basically there just to get people into the cloud. And that sucks because I spent a lot of time and money building this thing. And I don't want to see it just kind of being used like the on-ramp for an interstate. So the premise of today's episode is that our enterprise networks are really just becoming on-ramps to cloud service providers. Now, we have a lot of experience here in the industry of building these enterprise data centers and even some service provider transport layers. I'm going to open the floor up. Has anybody seen this shift affect either themselves or their customers in a massive way, where the former grand RFPs that could probably crack a coffee table in half when you set it down have suddenly become super thin, because basically it's like, give me a fast internet pipe and some wireless access points so that I can get to Amazon?
We're seeing both. We're seeing customers that are continuing to do their enterprise networks. Healthcare, for example, it's really hard to take that network and virtualize it when you have bedside monitors all over the place, things like that. So there's a good example of the converse, if you will.
It's actually a really good point, because there are a lot of industries that have very immobile data, either because of size or because of regulatory requirements. Healthcare is probably the biggest corner case example to everything that we've ever tried to build. Oh, you want to do that? Oh, it doesn't work in healthcare. So I definitely see that being more of a sticker here. But it's interesting that you brought it up, that the reasoning why is not for things like EMR or HIPAA, but for IoT. So do you think that IoT is going to bring back a reliance on local networking, even though those IoT devices by and large do have cloud check-in capabilities?
I think it really depends. It depends on the kind of company you're running and what kind of business it's in. Let's take another example. Instead of healthcare, let's take a look at manufacturing. Manufacturing uses a lot of IoT. So there's another example that's very similar to what you just said. However, if it's a software development firm, maybe it is all in the cloud.
It's a good point. Now, I'm going to open this up to Chris or to Pieter-Jan. Yeah. I mean, what are you guys seeing?
Well, I think that you're partially correct on that it's an on-ramp to the cloud services, but for every different network or services that are running on your enterprise network, they have their own on-ramp. So you're still building an enterprise network, but with individual on-ramps for each individual service. Like video will probably be local. Yeah, sure, there are cloud service providers, but video surveillance systems or video editing environments, they're all local data. You don't want to push all those terabytes up to the cloud. you store that locally because you want to have that local speed. So it's really depending on the use case. And back to manufacturing, another industry that comes to my mind is logistics. The warehousing have a wireless network with all the conveyor belts being controlled with what we now call IoT devices. That's all local data. So the enterprise networks, they're changing, but we are starting to manage them as a cloud service provider. We are pushing, and well, that's a beef of mine, intents to the network. So we provision the networks based on the intent that we want to have on the network.
I mean, you're not wrong, Pieter-Jan. One of the values that cloud has brought down into the enterprise network is this idea that networking should be able to be configured easily and quickly by a number of, policy driven things. So I'm no longer hiring keyboard jockeys to sit out there and type away VLANs. I just say, I would like my network to provision for this thing. And the system automates that piece out. But in a way, if my network is overly simplified anyway, why do I even need that? I need essentially VLAN 1 to exit to a router somewhere, because even all of my security functions are slowly being taken over by the cloud. So you've noticed that when you talked about, well, I don't want to push all that data up to the cloud. Well, what if I do? What if I want to wash through all of the analytics that my employees are doing to make sure they're not going places they're not supposed to be? Well, that's why things like SASE were invented. So in essence, my data does have to go to the cloud in order to be checked out.
But only metadata, not the actual data. Like what I gave the example of video data, a video editing studio, they will continuously store the data local because the cloud will be too expensive to store all those terabytes of video data and manage it. We don't have the bandwidth in the gigabytes in the cloud, not in the gigabits, not that speed. But back to what you say is just give me a VLAN, even that flexibility, every individual function that needs to go onto the network, which is not only my Office application, it's video, it's IoT, it's the video surveillance, tags to get access, they all have their own individual requirements. And those requirements make that we need to have our networks programmable. So you see that the traditional enterprise network is changing, and we want to do things via the policy because we want to be future-proof. Now, before COVID, I would say that the network is actually changing, and we're putting so much more in the enterprise networks. But with COVID and everybody is working from home at the moment, my opinion has been changed a little bit. But now when we're going back to the office, even part-time, we are doing a lot of things using SASE clients and policies, but each with their own individual things. And those individual policies make that the enterprise network is changing. We still need that wireless network. Wireless is the primary connecting factor. You need to have that infrastructure in place to provide the wireless services and the best experience to each individual user. So we still need to manage them, but we are starting to manage them in a programmable way.
And I would say that the majority of people that are managing those networks now are managing them in the cloud. They're using cloud controllers to get visibility into everything going on across all of their sites. So even though the traffic is exiting locally, whether it's to be direct internet access or to be some kind of local storage option. Now, one of the other things that I would bring up there is it's cheaper to buy more bandwidth into the cloud than it is to replicate storage units. For things like video editing or data that we want to survive. I mean, we could go back to the tale of Toy Story 2, where it just so happened that the only person who had a full working copy of the movie backed it up on a laptop to take it home to work on it. And I promise you, after that, suddenly Pixar had a lot more backup options. But now, when we think about the possibility that work could be lost if someone's hard drive fails or a server hard drive goes out, we might want to consider storing that in the cloud, which means that the ability for our high-speed networks to get to the SAN on our local machine, when the SAN goes out, well, if it's going to cost me $50,000 to replace it, I can get a lot of bandwidth in Amazon for $50,000, and elastic storage is fairly cheap.
Yes, but in those sizes, if you talk about terabytes or even petabytes with data deduplication, raw data being transferred, it's going to be quite expensive. So from a disaster recovery perspective, you are right. But to use it in production environment and have that high-speed video editing requirements, I think that's not going to work. Even in a high bandwidth country like I'm living in the Netherlands. And I'm spoiled with my 500 megabit internet connection, but it's only 40 megabit upstream.
And there's the whole factor of latency. If it's in the cloud, doing video editing over a high latency connection just doesn't work well.
Exactly. And what happens if that cloud, well, sorry, we had a failure in our storage system, your data is lost. There's no guarantee that they will recover it for you because you're not paying for that, quoting Tom's post from a while back.
That's true. You can't expect the cloud to be fully redundant for your data. It's fully redundant for everybody's data. But I think that the amount of redundancy that's built into the cloud by and large is better than what most people have been building on site. I remember working with certain US federal government programs where if you said the R word in a proposal, redundant, or use the word backup, your proposal was shot down immediately. So therefore, all of our secondary supervisor engines and our switches suddenly became load sharing supervisor engines because load sharing was allowed. And we all know that when we say we need you to buy one of these in enterprise IT, what we really mean is two. And if we say buy two, we meant buy four, because you want to have additional capacity necessary when something breaks. Chris, I want to give you a chance to jump in here from your perspective, because I know that some of the stuff that you do actually does work kind of in the service provider realm. Are you seeing enterprise IT networks slimming down in favor of just pushing everything back up to the cloud?
So I'll start off by prefacing that I do live in a different world. It's a bit of a bubble, living in research and education networks. But we are seeing the same trend happening where, you know, as a service provider, you're starting to see a lot more of our flows are headed to cloud providers, and, you know, a lot more work is being put into providing lower latency, higher bandwidth access to those cloud providers from our perspective. Backing up as well to the enterprise concept, though, I've worked in heavy industry and manufacturing in the past as well, and a big part of that was needing the data locally because we didn't have connectivity to the cloud. We didn't have the connectivity to anywhere. You know, at best, you know, one of our sites had a 4 megabit per second bonded E1 satellite connection with about 1,000 milliseconds of round trip time once it got off the nested providers networks. So there are still some places where cloud is not the option, but I think that those are definitely becoming the exception, not the rule. So back to the premise of whether or not we are just becoming cloud service providers, I think in the enterprise, we're definitely leaning that way. And I'd have to say I generally agree with the premise. Of course, it depends. But I think for a lot of, you know, just regular campus enterprises, you just need access to the internet. That's it. And you don't need much more. And that allows you to simplify your designs quite a bit. And that's why with technologies like, you know, software-defined access that I think are really cool, I kind of wonder if they're starting to come a little bit too late to really matter for the majority of enterprises.
One of the interesting things, thinking about, okay, so how do your bits get to the cloud? There has to be some network infrastructure. But then I was also thinking about this whole topic this morning and kind of preparing for this discussion. And it's like, okay, so what if I just use 5G? I mean, there's lots of promises of, you know, gigabits of bandwidth over 5G. Do I even need local wires, fiber, routers, switches? Do I just connect up my stuff right through 5G directly to a carrier? Interesting thought.
It is interesting, but personally, I expect 5G, if you want to have those gigabits, every LAN post here over every 50 meters needs to have an access point, just as a high density wireless, because otherwise I won't be able to provide aggregated gigabits to every individual user. So then the problem becomes a problem of a service provider. But that's probably a different discussion.
I was postulating that the service provider that's providing that backhaul from all of those lampposts is a cloud provider, basically.
It's just bits transferring the bits to the cloud providers besides doing phone calls. And personally, I don't think that any large telecom provider will actually start doing that. But that's my opinion. That's my personal opinion. But that's a different topic, probably.
From a service provider perspective, I think that we're seeing a lot of changes in traffic flows from being not as much any to any as more, any to a few destinations, which are pretty much your big cloud providers, your CDNs. But traffic is pretty much either local from a caching appliance for a CDN or Netflix or whatever, or it's going to a cloud provider. You have almost no eyeball to eyeball traffic, very little at least. And so peering and tier ones and a lot of that really are I think they're changing a lot. And the concept of a tier one is, I don't know, not as much of a thing anymore, really. There's just so few networks that are actually peering with everybody as the number of networks have exploded. And, I really do think the internet is moving towards a more centralized, it's still, of course, the decentralized internet model, but it's moving towards a more centralized cloud provider. I connect an eyeball to the cloud, and everything else, it just goes through my transit, and that's it.
Almost as if there were a bunch of clients that needed to see information on servers somewhere. We've just changed the location of the servers.
Yeah, it's the whole paradigm of networking as a service.
Yeah, I want to confirm on what Terry said. It's network as a service, and that's what I meant with the intents. And sure, most of the applications are running in the cloud, and there are other industries, financial, government, we had medical care, logistics, manufacturing that have local data. But even with IoT sensors and big data, you might want to keep that local too for the analytics and machine learning. That could be another reason to have some data on your locally managed data center, considering it as an offsite cloud. So not everything will be in the cloud, but it's probably going to be a mix. And from an enterprise perspective, we need to provision both the on-ramp to those cloud providers and to that local data center, which is still there for some corner cases.
I'll be curious to see if that holds true, or if the promise of edge computing and 5G, since Terry brought it up, if 5G delivers on that promise of edge computing where you don't need that. Personally, I don't think it will, just because I see how poor the infrastructure is at a lot of these facilities where edge computing is going to go, and you don't have power. Data centers are not measured in fiber bundles or square footage anymore. They're measured in power, and that is the number one constraint at all of these, places where you would be putting the, edge, right? But so I'll be interested to see if that plays out. I'm definitely curious. I don't know. I don't have a good answer.
All right, I'm going to open up to a similar topic here, security. Where do you put edge security in this thing that connects right to the cloud is your network, or networking as a service? Tom mentioned SASE. He didn't mention, well, I guess a part of SASE is the zero trust network access. So where does all that stuff go to protect your IoT devices and the devices that are basically vulnerable on your network?
So let me kind of riff on that thing that I brought up, Terry, because that is a good point. We do have a lot of insecure devices out there by design. I mean, you don't make money off of IoT by making it the most robust client ever. You put the cheapest radio in that you can, you give it cloud management software, and you run with it. So a lot of companies that are developing SD-WAN and especially SASE are kind of putting that security burden on their back and carrying it by forcing traffic to go into a cloud access service broker, for example, CASBs, to do the traffic and security engineering. So in effect, they're trying to make zero trust architecture out of the edge network by forcing all the traffic into funnels where it can be washed, cleaned, analyzed, inspected, and eventually sent back, which creates another bottleneck, because now my traffic can only scale as fast as my CASB can scale, which right now a lot of them are based in the cloud. So it's not as easy as, like, oh, I'll just put an agent on every host. Well, what if your hosts don't have the capability to install agents?
Yeah, I think you'll start to see if this whole promise of funneling everything to the cloud in that manner really takes off, and I think it will, because local firewalls and inspection, a lot of it's really changing, and being able to inspect on your big monolithic next gen firewall stack is getting harder and harder every day. I really do think we'll start to see it funneling to the cloud. And I think in general, the gigantic stack of firewalls is just, I think it's kind of going the way of the dodo.
It is. I think next-gen firewalls are obsolete because of all the encryption by default. So it means you can't really inspect the traffic anymore. But the scalability of those Gatsbys, when you're funneling all the traffic and you're going to large environments like buildings with 7,000, 10,000 employees, high-density wireless networks, you won't be able to scale that using the cloud. So that Gatsby will probably be coming back to the edge and funneled through your enterprise network to that Gatsby and then being brought to the internet for whatever destination.
Yeah, and that's where
then it's going to be circling back. So I think it's going to be a mix of both. Those SASE clients that you can manage, they will go directly to the internet via reason X, Y, or Z with some traffic inspection. And then you have all the bunch of other stuff that we are putting on the network that's insecure by default. Heck, my home has 25 clients, and I think only 8 of them are manageable. The rest is insecure by design. So I need to do something for them. And I'd rather do that locally before it goes into the cloud, which I cannot control.
Yeah, I was thinking about the security side of things, more like the devices, like the IP cameras that are vulnerable to just here's the carefully crafted 3 packets that are required to break into that camera.
So that's actually a good point, Terry. Right now, we have a defense in depth strategy. We have perimeter security, we have access control lists, and we have all of this whiz-bang functionality that is designed to prevent attackers from easily compromising a device. Let's be fair. We won't stop them 100% of the time. If they really want to compromise a device, they will. Well, all we can guarantee is that we're going to prevent them from doing it easily. It's like the the spam problem. We don't want you to eliminate it. We just want you to make it so expensive that you move on to another vector. But when you look at the way that most people are trying to solve this problem with things like zero trust network architecture, I mean, I've seen this before. Tunnels everywhere. So we're going to build a tunnel directly to the device, and we're going to make sure that nobody can access it unless they have this, what have you, this user authentication or this machine authentication. Okay, great. You've added needless complexity on top of my network, and you don't actually make it any more secure, because if anything can get inside the tunnel, then I've got a problem. I don't even have a way to create a flooding access list on a switch that says if this port is producing too many packets, you need to lock it down. Because we're oversimplifying our local networks, because that's not where the money is. The money is being invested in the cloud. I want to spend more money in Amazon getting my cross connects between my VPCs built out properly, because that will reduce friction, create efficiency, produce more profit, make my users happier. Especially when you consider that now half of them are working from home and I have no control over their networks at home. So are we really just kind of wagging the dog's tail here when we realize that there's a very considerable possibility most of us may never go back to an enterprise network. Our enterprise network will be at our office, at our house.
Could very well be. It'll be interesting to see how things turn out. And I think a large part of what's going to drive that is the whole security stance. How do we keep the bad actors out?
That's part of it. But Tom also says you create tunnels, and tunnels means network management, which means added complexity. And that means that I still need to have a complex enterprise network. Well, I have all these tunnels now that need to be managed and controlled. And I want to have it secure too, which means visibility.
I think I would maintain that the software-defined aspect of networking these days will help mitigate some of that pain.
I think
not all of it. Not all of it.
I actually think that it's the other way around. We need to have that software-defined access to define those policies, and make it cheaper and manageable and have these effective tunnels created by software and removed by software. So the enterprise network, traditional VLANs, classic, with spanning tree or without, depending on your preference and everything else, that is going to change because we're now making it policy-centric. So back to the premise, we are going to manage our enterprise networks the same way as we manage our cloud infrastructure, by pointing and clicking and having policies pushed to the enterprise network. But that enterprise network still needs to be there.
I think one of the interesting things that's going to happen is how do you go about defining policy and then turning that policy into something that can actually go and configure your network? And I'm not aware of a whole lot of work that's being done there.
Yeah, that's probably the golden bullet or the silver bullet.
But the clouds are able to do that. And I think that that's one of the things that's on the wish list of most customers is I want my enterprise network to have a cloud-like experience. And I think that it is a selling point for some companies that are doing it. One of the ones that I could think of is formerly Big Switch Networks, now a part of Arista, that said, oh, well, if you want to manage your internal network like you manage your AWS network, we'll give you that functionality. And that actually created a very important point for people, because now what is the difference in my enterprise network and my cloud network, other than, you know, kind of as Chris alluded to, the high-speed transport to get things off of my local loop into the cloud, because now it all kind of works seamlessly. And maybe that's the ultimate solution, is not that we need to transform our networks into on-ramps to the cloud service provider, but instead that we need to transform our enterprises into networks that more closely mirror the cloud, so that the users don't know the difference. The only thing that they think of is, well, I'm connecting to an endpoint somewhere, whether it's a wireless access point or an SD-WAN device that has a 5G uplink card in it. And from there, I'm in the cloud, whether I realize it or not. So maybe what do you guys think about that? Is the solution not to dumb down our networks, but to make them, you know, big brain, ultra smart, so that our users don't know the difference of where the cloud ends and the local network begins?
I would agree to that up to a point, but there's a clear distinction. In the cloud provider manages the full stack, and in my experience, what I'm looking at when you're looking at ARP entries and how traffic is handled in Azure or in AWS, it's all software defined, and they do some nasty tricks in things that we use ARP for. And in the enterprise network, you don't have control over all the endpoints or the underlying infrastructure. And with the cloud, my VM, which is running on that cloud, it's running some sort of optimized packet forwarding magic. And if you go into the gory details, in Azure, I know it's not really scalable with BGP, for example. And they're very proud to have like 2,000-3,000 routes in their BGP. Well, that's peanuts for an enterprise network. We are at a much larger scale. So mirroring, yes, in the behavior and the manageability, but in the implementation, it will be different, because we have a wide diversity of endpoints that are not completely in our own control, unfortunately.
Just to that point, Pieter-Jan, I think that the cloud trying to extend things like MAC address and ARP entries to do things that it wasn't intended to do is basically what we've been doing with networks for 20 plus years now. I don't think that we have the monopoly on stupid tricks with hardware to get it to do things we want to do. I think they're just doing it at a scale right now that we haven't been able to achieve yet. And anybody who's ever tried to create a RIP adjacency over an RSPAN port will be able to just nod their heads and agree here, because just because you can do a thing doesn't necessarily mean you should do a thing.
No, but they're not following the layer 2 RFCs. For example, a packet within the same subnet is still traversing through a router in Azure, managed by Azure. That's some icky thing going on there.
Remember, an RFC is just a request for comments. It's not a rule for comments. I know what you're saying.
They're not following IEEE standard.
Chris, Terry, what are your thoughts? Do you feel like we should make our enterprise networks super smart so that they look like clouds, so that our users don't know the difference?
I think we should make them dumb. I think in the main case, we should make them dumb, because the less there is going on, the less there is to break, the less there is to compromise. I think the general case is that enterprise networks are going to be dumb cloud on-ramps. And I think that in the more edge case, that there's going to be, where you can't have managed devices, IoT manufacturing, then you're going to need that really smart network. But I just really don't think that most enterprises need a lot of the stuff we've built. As much as that pains me, because I've also built a lot of those really cool things.
That I think there will be dump on-ramps for each individual group of devices. And on enterprise networks, there will be a high diversity of groups of devices. And we need to manage that in one way or the other. And that brings us back to the software-defined access or intent-based principles. So from a user perspective, they will be dump on-ramps, but to manage that in such a way that you don't have cross-traffic or cross vulnerabilities because of all these unmanageable devices, that's going to be a challenge.
There's I tried quickly looking up the end-to-end principle. Okay, everybody should be familiar with that if you're doing networking. Time and time again, we've proved that smart networks get stuff in the way that makes it hard. And moving that intelligence out to the edge makes it easy.
The more state we have in the network, the more complex it is, the more difficult it is to troubleshoot, the more it fails, the more it breaks.
Unless you start to manage it by exception and use machine learning and intelligent analytics to validate that everything is working as designed and just get the exceptions out. So why would we want to do things traditionally and keep control ourselves as a human? Why not leverage the power of models and analytics and model-driven telemetry and all the other nice stuff to do things for us? And that's what I see quite a lot of network vendors do with their AI-enabled networks.
That works until you get into the corner case where it doesn't.
Oh, of course. And that's why we have a business, right?
That allows us to continue with our jobs.
Yeah, because nothing is more creative than a human being wanting to keep their job, or an AI algorithm that is so completely confused that it has no idea what's going on. The difference is the AI algorithm will eventually quit and humans won't. And maybe that's kind of ultimately where this whole conversation leads, is that we have a lot of emerging technologies that are in the enterprise network that we need to consider. It's no longer just EIGRP and OSPF connecting workstations to the data center to edit video. Now it's IoT devices on the edge. It's 5G wanting to get our clients connected more quickly. It is content consumers that are pulling down lots and lots of things from content delivery networks that are pre-positioned in our environments. And it's a lot more complicated than we really want to admit when we think about things like zero trust and cloud security. And the real solution is that you need to take a step back and figure out exactly what you need. If your users don't live in your network anymore, you don't need to put a lot of effort into building it out. If your users do live in your network, you need to understand what their traffic patterns look like. Do they need local access more than they need the cloud? Do you need to make it easier for them to get in there? And honestly, maybe the solution is that you just need to get out of the way and let the network do what it needs to do to get your people where it needs to go. Because as we kind of closed with there, the more creative you try to get with the solutions to make things go a little bit faster, the more likely you are to collapse the whole system in on top of itself and create a massive furball that you're going to have to spend years unwinding, which is great for job security, but not so great for user happiness. And ultimately, that's our job, is to just try to keep the users happy for one more day. All right, that'll just about do it for this episode of the On-Premise IT Roundtable. I want to thank all of you for tuning in. If you want to hear more great networking conversations like this one, please make sure that you tune in for Gestalt IT's Networking Field Day 25, which will be taking place May 12th, 13th, and 14th. All three of the guests here today will be delegates at Networking Field Day, so you won't miss out on any great conversations that will be had, because they'll be leading them along with another great group of delegates. If you want to find out more information about that event, please head over to our website at techfieldday.com. Click on the link for Networking Field Day 25 and check out the list of delegates, check out the list of presenters and the schedule. If you are listening to this episode after May, please make sure you head over to our YouTube channel at youtube.com/techfieldday, and you can catch the recordings and all of the great content and discussions that happened there. If you want to check out more episodes of this podcast, please make sure you head over to gestaltit.com/podcast. That's always where the latest episode can be located. You can also check out our YouTube channel at youtube.com/gestaltitvideo. For now, for Tom Hollingsworth, for our great guests, and for all of the people in the Gestalt IT community, I want to thank you very much for tuning in. And we look forward to having another great debate about an interesting IT premise with you very soon.